primary. Just because this is drawn like this doesn't mean it has become secondary, right? Yes, but of course, this is secondary on what basis? Now, this carbon attached to how many other carbons, right? This is your okay, tertiary, right? So secondary like this, tertiary and primary, right? Yes, right? Now, all the three cases we have, they will undergo nucleophilic substitution reaction. Yes, right? Okay. Now, nucleophilic substitution reaction means what? That we have to break the CX bond and a new bond has to be formed, right? Okay. So, if we talk about the, right? So, what is going to happen? This has to break, right? And suppose the new nucleophile, I name it as NU, right? So, this need to go and this need to come and attach itself to the carbon. That is what the whole thing is about, substitution, right? This need to go. Now, in how many ways do you think it can happen? Can it happen in one step? No? Yes? That this goes, simultaneously this comes in attack. Can it happen? From one side, from this side the X is going, from the other side the nucleophile comes in attack. No? Why not? Why not? Why it cannot happen simultaneously? Why do you think it can't? Okay. So this is what we have drawn it as a 2D this thing representation, right? Otherwise, what is the structure of a carbon attached to 4 other bonds? Tetrahedral. It's a tetrahedral, right? So if you have a tetrahedral, if something is going from here, can something comes and attack from this side? Why not? Why not simultaneously? Yes, there should be space for it to come and attack, then only it can attack, right? So you are saying if we have something like this, right, and X is going from here, the nucleophile can come and attack only if there is a place, right? If there is no place, then there is, what do we call that? Steric hindrance, right? Because of the bulkiness of the group, the hindrance which is provided, we call it steric hindrance, right? So yes, this is possible, but only if there is a space to come, right? What is the other possibility? So this is one possibility, that it comes and it attacks like this, right? What is the other possibility? That is the worst. Okay, the other possibility is?
Carbocation is formed.
Okay, the carbocation is formed. So in the first step, this goes out, right? What do I get? A carbocation, right? In the second step, the nucleophile comes and attack this one, right? Do we know how to make the arrows? And what are we doing? What do we call this? These steps what we are writing with the arrows, what do we call this? Mechanism, right? This is a mechanism for the reaction, right? So this one will give you this. Yes, right? So these possibilities are very much there, right? In one case, first your carbocation is formed, then it is attacked by the nucleophile. In the second case, you are having the nucleophile coming, but when this comes and attaches and this goes, what is that state called? What do you think? Is it going to be a stable state? The carbon is surrounded by 5 groups. Will it lead to a stable state? What do we call that state which is not stable but it is moving from one to another? Transition state, intermediate state, right? Transition state, right? So in this case, it will lead to a transition state where the carbon is surrounded by 5 groups like this. And it is going to be highly unstable, right? We call that as your basically transition state, right? Which in the next step will lead to X moving out and nucleophile forming the bond, right? Yes. Now the question is, tell me, for secondary we'll leave it, primary and tertiary if I compare, right? Which one you think is going to prefer if these are 2 different mechanisms? This is one step mechanism. Is it one step mechanism? Yes, all of you? The nucleophile attaching, X going. It's a one step. This is 2 step mechanisms, right? Okay, formation of the carbocation. The second is the carbocation getting attacked by the nucleophile. Out of the 2 mechanisms, which one will be preferred by the primary? Which one will be preferred by tertiary? Think and then answer. Just raise your hands. Yes, Pratika, right? Yes.
Tertiary will be second step because it's not so easy.
So you are saying tertiary will prefer this, okay? So you are saying tertiary alkyl halides will prefer this, okay? And the reason being?
Because there's no space available, so it has to become a cation.
Great, because you are saying that in this case, it's not, the steric hindrance is not a problem, right? Is this right? All of you? So one thing we can say, the tertiary is preferring this one because it leads to the formation of carbocation and doesn't lead to the steric hindrance where the three groups are already there and somebody has to come and attack. Perfect. Anything else you can think of? Okay. So you are saying that tertiary carbocations are more stable. Very nice. Tell me why. So please write. Write that. So I would like to know the reason for this one. This is clear. This is clear that tertiary will prefer this, right? Okay. Due to inductive effect, okay. Now you are saying the tertiary carbocation. Now what is a tertiary carbocation? Let's take an example of that. Or look at the board. Look at the board. Let's finish with this thing first. This is called, if I say one of this mechanism is called unimolecular, the other one is called bimolecular. Okay. Now look at the board, please. In this case, your first step, Jonathan and Isha, the first step is a slow step that I am telling you. You won't know, right? But this is a slow step, this is a fast step, right? Does the slow and the fast step has to do anything with the order of the reaction? Kinetics? We have done kinetics. Okay, when anyone? Yes, Harsh? The slow step is the rate determining step. Now in the slow step, how many reactants are involved in this case? This is a slow step, this is your reactant. How many reactants are involved? One. So can I call it unimolecular or bimolecular? Can I call it unimolecular? Right? Because the slow step, which is a rate determining step, is involving only one molecule, right? So that's called your unimolecular reaction. What about this mechanism? It has this as well as this. Both are involved in that single step mechanism, right? So this is called your bimolecular because both the reactants are involved. It's only one step. One step mechanisms are called elementary reactions, right? Right. So this one step involves both the reactants, right? So that's called your bimolecular reaction. We'll continue that later, but let's end with this thing. This mechanism is called SN2 mechanism, okay? And this mechanism is called SN1. Now that 1 and 2 makes any sense here? 1 is unimolecular, S is substitution, N is nucleophilic, 1 is unimolecular, that's your bimolecular, right? Have you understood the difference between the two? Then we continue that in the next class. Thank you.